I'm Mark Sampson. I'm the chair of the Model-Based System Engineering Initiative. Troy Peterson is here with me, my co-chair, and we have a lot of stuff to get across to you guys. But before we get started, we're going to have, we decided this year to ask some of our fellows, INCOSE fellows, to join us, and we got 4 volunteers, I guess we'd call it volunteers, that stepped up, and so it's going to be an interesting experience for you to talk about, to hear what they have to say. So before we ever start, those of you who have been in these model-based system engineering workshops and otherwise, we always start with a reason why. When my teenager arrived at teenagehood, I discovered that you have to start with why everywhere. You have to begin with a why. And so the reason why we're doing model-based system engineering is to achieve this vision. And you may ask yourself, what does this look like? What does an integrated model-based system engineering thing do and look like? So if I had a vehicle, and I could ask that vehicle questions if I had this model-based system engineering environment available, and that vehicle could tell me things like, for example, what are the requirements? Here's 2 requirements, one for turn radius, one for braking distance. And what would happen if I changed that braking distance from 110 feet to 90 feet? Now in your organizations, when that happens, that causes a trade study, weeks, days, weeks, months, even years. Some happen in some complex situations to find out what the potential impact of that change is. But because we've got this integrated model-based system engineering environment in place, we now know pretty instantly these areas of the vehicle are potentially impacted as a result of this change, and we can drill into it, and we can see the brake system in this case. You can see the hydraulic fluid is no longer compliant, the thermal models are reporting we got an issue, hydraulic pressure seems to be okay, but for some reason we've gone to a fault in our automatic cruise control. We see a problem with our mean time between failure calculator, and for some reason we've now gone to 18 amps in our electrical circuit. So we drill into our electrical circuit and we can see we've blown a fuse. Why have we blown a fuse? We follow that to our schematics. We see for the first time a relationship here that we never realized existed before. So when that sensor failed, it caused a cascade. So we go look at that. And now while we're here, we might as well go ahead and put a new failure mode in that we have to keep up with. So there it is. And we might as well go look at the MATLAB model which generated the code for this thing, the brake system. So let's go get that fixed. And while we're here, we might as well look at the actuarial table because we should be able to get a better insurance rate, right? So all these kinds of things are now involved in this process, and that's the value we're getting from an integrated model-based systems engineering environment. So I typically give an update based on the fact that my son was essentially 7 years old at the time we first started these workshops. And so I decided to use him as an example of how things are in the world, in his world, because he's grown up in a model-based world. When he arrived, just like those of you who have children, your lives changed, right? Okay? Suddenly it was a pretty dramatic change, and we started into the patterns. So for example, we get ready for bed, we brush his teeth, get him in the bathtub, get him in his pajamas, we'd start reading, we do reading every night. And one night, as we're reading, I noticed my son, he's now about 18 months, I noticed my son is reading what's on the pages of this book. This is the book Good Night Moon, those of you that remember that book. And I said, oh, of course, we've read this like 3,000 times, he should know this by now. And so I flipped the page and it says, AJ, that's his name, can you read this page? And so he started reading the next page. So here he is at 18 months, and he's reading the contents of this page. I said, it must just be because he's read this so much. And so I went and grabbed another book and opened it up, and he started reading. He's reading at 18 months. He's what they call spontaneous reading. It turns out when you ask the experts about this, it's something about pattern recognition. He's recognizing patterns, and once you explain the patterns to him, then he gets it and he starts doing it everywhere. And they propose, what they recommend is that you start explaining patterns everywhere. Start reading everything in sight to this guy. And so stop signs, we're reading yield signs, speed limit signs, and he becomes a pretty good backseat driver, always nagging us, okay? And then when my wife would take him to the store, she would read the ingredients list to him and that sort of stuff. And remember, a lady came up to her and asked, that's so cute, you're reading the ingredients to your 18-month-old. And my son says, my mother wants me to be an informed consumer. That's what he says. And it got to the point where you don't recognize this anymore. It just happens so often, you just kind of go on with life. And every once in a while, he'll show up with something new. So at 11 years old, our city bought a new tar machine. And this tar machine, they'd go around and fill the tar cracks in the streets, right? That's what they do. And my son runs in from grade school and he says, hey, Dad, come out here and look at this. Now, nobody else noticed this, but he did because he's recognizing patterns. The pattern you can see that he's recognized here, you see Joe, and you see January 5th, 2012. The guys who are doing the tar are so bored, they're breaking patterns and drawing things in the tar in the street. And so he's recognized this thing, and everybody's going by this thing, and it's been there, and ever since, and we noticed nobody's recognizing this, but he's recognizing because he noticed the patterns. So let's see how good you guys are at recognizing patterns here. Who can tell me what's wrong with this problem? This is an actual recall, vehicle recall in the United States. What's wrong? See if you recognize the pattern. Turns out, as you're cruising down the road, you notice there's the drive selector. As you're cruising down the road, and you reach over and turn off the radio, you turn off the vehicle. Locks up the steering wheels, locks up the safety systems, you know, et cetera, et cetera. That's a serious problem. This has turned out to be about 1.4 million in direct costs. Luckily, it didn't kill anybody, but it was one of 37 million recalls that year. The National Highway Traffic Safety Administration says that each recall costs about $100 per recall per vehicle, so you can see that we're talking some serious money here, okay? How about this one? Do you guys recognize this pattern? We'll step back so James can see. Material science will probably pick it up pretty quick. That's a zinc backplate that's been directly mounted on top of a steel cross member. And you guys have been in engineering school. What? They did what? How come we put zinc on steel? What's it going to do? It's corrode. That's a fuel pump control module. Okay? And of course, it's going to destroy the fuel pump control module, and your car will stop because the fuel pump stops working, et cetera, et cetera. This one was going to cost them 86,000 vehicles, about $8.6 million to do this kind of pattern. Now, it turns out what we're after doing is these are, once you've had one of these experiences, yeah, you recognize the pattern, but before, it's a surprise to you. Now, we can have a different discussion about how we make sure we don't lose those lessons, but that's a different conversation. But the important point here is model-based systems engineering integrated with the entire life cycle is supposed to be proactive and let you know about these kinds of experience. So much so that when you were, say for example, placing that thing, you're in the CAD world doing your thing, this thing shows up and thinks on you and says, hey, don't you realize that you're putting metal on steel, you know? Or something like this here, I'm looking at the thing and there's this highlight to me, or even this one, you know, say, hey, you got a problem here. Doing this all in advance before it gets out into the field and we got these real problems. They're going to cost us lots and lots of money because now you'll notice also these things happen at the boundaries of disciplines and domains, and the model-based system engineering has to be cross-domain and stuff like that. So what we're about to do here is we're going to launch into this lightning round, and now that you guys know and you're all fully motivated about why we need this integrated model-based system engineering capability, we're going to have a presentation by Ron Carson, Dr. Ron Carson here. He's going to talk about system architecture model use of structured requirements. He's going to talk about that. We have a dynamic duo from Purdue University, Dr. Bob Kinley, and one of the graduate students over there. I guess they talked to us, it's going to be pretty exciting. We'll see how he does. And Robert Stevens here. We got Professor Heinz Starr who's going to talk to us about the importance of model-based system engineering to enable digital enterprises. And James Martin's here with us to talk about architecting models, after which we will go to a Q&A session. So you're going to hold your questions. We have no time for questions or interruptions. It's going to be 18 minutes per. We'll have a 2-minute break, like 2-minute transition time in between things. And then we'll end, at the very end, we'll have the question, Q&A. Those will be the most interesting part of this conversation is at the end here. So with that, we're going to turn the time over. Who's up first? Dr. Carson, you want to come on ahead up here?